Next up, we have Benjamin Schönbach from Denic, and he's going to present his research on the performance of authoritative servers in different environments. This is going to be quite interesting.
Yeah, thank you very much for invitation. Once again, my name is Ben Schönbach from Denic.de. I would like to show you the approach for our Anycast stack, which is quite flexible and highly performant. Some time ago we had to renew our infrastructure. At that time it was based on a hypervisor concept where each customer's name servers was running inside a virtual machine. It was powerful, it was reliable, but it was a little bit out of time. Even it took 1 or 2 days to set up a new customer around the globe. That's too much time according nowadays challenges. And that's why we decided to have 2 solutions in future. One is a bare metal approach, which uses just isolated path resolution in change root environments. And the other one is just a true virtualized approach using true namespaces with isolated path resolution, with isolated PIDs, isolated user IDs, and also virtualized resources. Yeah, that's what we did, and it was worth enough, I can tell, to implement both, because if we are facing clouds and so on, it's you have to be flexible as possible. Just one reminder here, the Notion Anycast Stack here covers all the software part. It's not only the name server themselves, it's also the stuff we need for monitoring, logging, maybe also software routing if it's not an on-prem location or something like this. Okay, moving on. Just 2 more sentences on motivation, because the most guys of you are much older and wiser than me, and I guess you know the challenges of our time. One point is geopolitical crises. I know you all know what's going outside the world on. Yeah, we have more and more unnecessary wars. Sabotage is coming in, sea cables are broken and so on. So you should be able to migrate your name server location as fast as possible from one node or one location or one country to another without doing much maintenance on the stuff. And the other thing is what we are at least facing in Germany, an old generation is moving out and we are losing expert skills. The younger generation is developed on a different scope of knowledge, and it's hard to find system administrators and true network engineers. Yeah, that's also one thing we are facing. That's why your stack should be easy and keep it simple, in my opinion. Yeah. So just to give you a little bit better overview where this DNS Anycast stack is located inside our infrastructure. This is just a little bit big picture, starting from the left to the right. We receive our zones from our Anycast customers inside our data centers. Then we are analyzing the zone, we are backupping it, whatever the customer is preferring. Then we are sending it out to the name server locations. And here we distinguish between 2 types. We have virtual name server locations running on cloud, and the other one are hardware-based name server locations running on-prem. Yeah, having a more detailed look on this bare metal approach, it's quite simple. Again, from the left to the right, what do we have? We have our hardware. Then we have our kernel, and upon that we have the user namespace. It's a common user namespace, but every customer one-to-n is running inside jailed root file system. But it uses the same resources, so there's no virtualization in between, there's no network address translation between those change root environments. And yeah, for each customer there's running at least 1 name server. The software, it depends on the customer, whatever he wants. Usually we have NSD, not bind running, whatever he prefers. Besides, there is some common processes running, like for monitoring, logging, and for API stuff that we can access the name server location from the outside world. So that's it from the detailed point of view. How does the virtualized approach look like? Well, it's better known as using containers. So what do we need above the kernel space? We need at least an ORCUS container runtime environment. It's up to you if you use container daemon, Docker, Podman, whatever you would like to have. And on that, for easier, let's say, managing and orchestrating of the containers, we use an orchestrator. In this case, we use a lightweight approach of Kubernetes clusters, which is called K3s. It's just a simplified stack of native Kubernetes, which needs less maintenance than a true Kubernetes cluster. And upon that, we have multiple namespaces running. In each namespace, there's running the name server of the customer, also the, let's say the monitoring part, and so on. And the difference is here we have virtualized hardware, virtualized Ethernet devices, RAM, CPU, whatever. So this is how it looks like. And now I would like to show you how this works in general in our daily pipelines and so on. So what I try to do now in live mode is I will try to set up a name server location which is closely located here to Washington, D.C. It's a virtual node. It's running inside the cloud from a cloud provider. And I try to set up 3 customers. These are not true Anycast customers. It's just one for .de. Then we have this thing called enum. I guess you know all this thing better known as telephone number mapping and so on. And then we have some private zones like .denic.de, denic.com, which is called in our customer NIC. And these should be applied to the location. So let me just rearrange my displays here a little bit. Takes 1 second. Hard to catch. So coming back. So we have 2 terminals here. It's a little bit, for sure, it's a little bit too big. Just give me a second. Maybe this way. And there's also a second terminal we need for the liveness of the containers, which we will have to see. Just give me a second. So maybe this way. Still too big, not easy to handle here, not in mirror mode, I have to say. So, but again, so from your perspective, it should be this terminal will be first. Now I will apply the name servers. So this takes a moment. They will come up, and then they have to fetch the zones because this is a complete empty node where no zone data is pre-located right now. So in the meantime, we will have some views on a performance analysis, but let's keep it running in the background. So the first thing what I have to do is I have to apply all this stuff. For this is Kubernetes based, so you have manifest, it's YML files, you just need to apply them. So, and that's why I try to use this time command. Yeah, this one here. Give it a try. So what's now happening on the left terminal? You can see some namespaces are created for the customers and some other stuff. Yeah, this is quite the fast part. And is it going down, or is it just because it's now waiting for fetching the zones, I guess? Yeah, it's just going. Sorry. As you can see, yeah, just a little bit above. Okay, I will show you at the end. Just the right terminal is now more important. So what we have to do is we have to watch the name servers if they are serving the zones. But because before you can serve zones, you just need to have it on the location. Yeah, so there's a little bit. Currently, there's only 2 customers running. One is for .de, the other one is NIC, and the other one is enum. So enum is quite fast, and NIC also. So let's do it a little bit more bigger, this approach here. So let's do it again. So then let's do it. That's old-fashioned. Sorry, space in between. Yeah, okay. Try to limit it to 1 namespace. Yeah, so the other 2 ones are running. So .de zone is a little bit bigger, around about 2 gig, so it takes more time to fetch the zone. In the meantime, let's have a look on the results, and at the end we will see how long it take to come up again. And we will put it into writing and see hopefully some traffic. So coming back to the slides, just give me a second. Once again, F5. So this is running. Yeah, performance tests. Why is it important for us? Because we need to pre-calculate how many customers can we put on the node. So we need to know the upper boundaries. And as you can see, we did some performance analysis for the virtual approach and for the bare metal approach. For here, we start with the on-prem hardware, 48 cores on AMD stuff. And as you can see, we have here round about 1 million queries until it starts to drop in high peak. But as you can see, comparing this to our overall queries around the globe with all customers, we are just around about 200 queries per second. So this is high enough above what we need in the end. But this is just the upper boundary. And if we have a further look on the other, let's say grid customers now from 8 cores to 1 core, not surprising, somewhere in the range of 100,000 queries here. Yeah, that's the scope of the virtualized approach. And what about the bare metal? Yeah, not surprising, you can reach up to 2 million queries per second. Yeah, because one important thing is you don't have network address translation here between the virtual layers, which costs a lot of time and is very performance consuming. Yeah, a clear winner here is not an NSD, but also bind has a significant performance, which fits a lot, I would say here. And the same thing for 8 cores to 1 cores down, somewhere in the neighborhood of 100,000 queries to 800,000 queries. This is the performance analysis, yeah. Now let's see what does this mean for this overall analysis and evaluation. It's up to you, it's hard to judge. I mean, if it's all about performance, on-prem and bare metal will always win, that's for sure, that's not surprising. But regarding this administration effort, I mean, virtualized approach is pretty easy to handle. You don't need that much system administrator skills inside. Regarding scalability, both are scalable, yeah, as you can see. So we're talking about 2 million, again, 1 million queries in peak. Setup time is short. I mean, it takes here some minutes on the virtualized approach. On the bare metal approach, it's a playbook you run, so it's labeled 1 hour or so, depending on the number of customers you have in the node. And both of them are portable. Yeah, setup time is almost the same, I said, but it's up to you. If you need high performance, use a bare metal approach. If you need mid performance and easy maintenance, then use virtualized approach using containers, something like this. So let's go back to the demonstration part. What does these say? Coming up again. Yeah, okay, just give me a second. This way. So, what does DE telling us? It's up and running, hopefully. And so come again. Yeah, 3 of 3 are running. I guess the same thing, yeah, for for NIC, for example. We see the same thing, and for enum it's the same. So what we can do now, check now the time. How long did it take? Hopefully I find the right terminal right now. Again, this one, I guess. Where is it? This one, hopefully. Yeah, now I have to slide a little bit up. It's going. Boop, boop, boop. I need to do it here on my mirror. Just give me a second, and I will come back, hopefully. Yeah. So it was 5 minutes and 20 seconds. For the overall appliement of these 3 customers. And now just let's see if we can put it into routing state. So we will announce now the prefixes. Just give me a second. Just move the browser here. So this is the location, and I will take only .de into routing now. So now we're announcing the prefixes to our IXP provider. And let's see if there's some traffic coming in. So let's go to our second. Yeah, it's already inside. Explore matrix, and let's say run the query. So let's do it a little bit smaller. can see the picture. Yeah, there's something, a line is upcoming. Not much queries, but 80 to 100, but not surprising. For .de, the most traffic is attracted in Miami. Yeah, don't ask me why, it's Anycast. It comes always different than you expect when you do something in the routing of Anycast. You know better than me. But yeah, this is how our stack working. As you can see, it's quite fast. We don't need much time to set up customers. We can delete them quite quickly. Yeah, that's it. So if you have questions.
Hi, Peter DeVries from Quotient Inc. Wondering if there's a reason you chose to use the Trudon environments versus also using containers on the hardware, and do you have any sort of unified orchestration system between the two?
Yes, that's what we use is this Kubernetes orchestrator. Before we did that, we were using just the native Docker approach, but it's really hard because you have to set up internal network, Docker network, and so on, and then it's going in the same direction as you have lots of system administration. Yeah.
Sure. So the hardware systems are also part of the kube control setup?
No,
Oh,
that's
okay.
completely different. I'm sorry, that's a playbook which is running before where we install a usual Linux kernel like Debian or whatever you wanted. And on that, we install this K3S approach, which takes just 5 minutes, and then you do this applyment, what I did here. Yeah.
Okay. All right. Thank you.
Hi, Ben. Thanks for the talk. This is Puneet from Google. I have a couple of questions, and I'll take the answers offline. One is around how well do the two environments work for when one customer is getting, say, a DOS attack or overload? And secondly, I think one interesting bit here will be disaster recovery or failure recovery. I have my own intuition of which one will be easier, but would like to hear your thoughts.
Let's start with the DDoS question, I guess. If some, let's say, location is DDoS attacked, we will do some laundry special feature where we have a mechanism which is called ARPA shield protection. So in that case, we can enable it for a dedicated location. What is happening in the background, the whole traffic is reattracted to our laundry machine. It clears the traffic and sends it back to the location. So this is how we handle with DDoS attacking with these two approaches here. And the other question was regarding this, what was it?
Disaster recovery or failure handling.
Yeah, if a node crashes, as you can see, we just completely wipe it and reinstall it. Yeah, that's what we do currently, if this was the question.
Do we have any more questions? There seem to be people lurking and then they went away again, which is slightly worrying.
So Warren Kumari, Google. In the performance stuff, you're talking about how a lot of the time is spent doing stuff like NAT and similar. Have you looked at doing things like just binding the instance into the namespace or using eBPF or any of those sorts of things to remove a bunch of the extra faff?
Yeah, excellent question. We are thinking about this, but didn't have the time for this. But yeah, that's the question. If you do that, you're doing, again, administration on a lower level. And then why do this container stuff? Then directly run native processes in this jailed root, and then you can do it the same way. Yeah. What is also pretty important here, why this lacks a little bit more performance, this virtualized approach, we didn't talk about routing. And on-premise location, we have true hardware routers. On cloud, we have software routing done by Bird. And it's not only about establishing BGP sessions, it's about learning routes. That's what the IXP sends you in. And depending on the location, some IXPs send you 10 routes, others send you 1,000 routes, and it takes a lot of time in a virtualized approach to put them from the virtualized namespace into the kernel. That's something also pretty, interesting. Yeah.
Okay, winding that one up. Thank you very, very much for your interesting talk.